everyone and welcome to new discussion which is GIS analysis part 6. After this we will also have one more discussion on this, and by that we will be ending GIS analysis part. As you know that this is in 7 parts, and the reason is obvious that GIS analysis is the main part of our GIS, and even the title of future lectures may not be GIS analysis, but they will be all part of GIS analysis, because before the GIS analysis lectures we discussed the different types of data, spatial data, non-spatial data, types of attributes and many other things, and then started developing our GIS database. So that part is over. Now most of the discussion in future we are going to concentrate mainly on the analysis part, and there should be that is the basically heart or key of the GIS, that a GIS user must spend lot of time on analysis and can create lot of good output and modeling and prediction maps and so on. So let's start with that. And in the previous lecture we were discussing about the connectivity functions, and under connectivity functions we have also touched about the network analysis. So in this lecture and next one we are going to discuss network analysis in much detail, because nowadays as you know the GIS is extensively being used for network related applications. For example, maybe in transport, maybe in power transmission, maybe in other kind of transmission, maybe gas transmission and other things. So because these are all the resource has to flow from one place to another, and therefore these are very, very important. Similarly, if we talk about the traffic, then you must have seen the apps which we are using, especially in metro cities or large cities, about these taxi operators apps like Ola and Uber. They too are using GIS, and along with that they are using GPS and other things plus communication technology, but in the background they are also exploiting this network analysis. So from that point of view also, and other day-to-day analysis of various kinds. If we talk in natural resources, then network analysis, though it might be one way in most of the time, but like in a drainage network or a stream network, that is also there we can employ network analysis, because there it is a little simpler. In most of the cases water is flowing in one direction, and same in irrigation networks, like in command areas, canal networks are there, and then main canal, then subsidiary, and then minor canal. So that there also the network analysis can be employed of GIS. So it is very important from all those perspectives. Now in network, what are the network elements? So network data sets are made of network elements, and mainly network elements you can guess very easily are the polylines. And these network elements are generated from source features. Obviously, when we say polyline, that means vector data, and which creates the the network of these polylines, and then the resource can flow from one end to another, maybe through distribution case like in case of canal, or maybe a contributory system like a natural drainage system or a stream network. So both kind of network analysis can be performed. Related with this natural stream network or these drainage system, we will be having much more discussion when we will discuss the surface hydrologic modeling employing digital elevation models. So there also this network analysis concept will be used. Now as you know that the geometry, network geometry has to be established in order to establish the connectivity among these polylines which are of our vector data, which might be residing in our database. And also in network elements we have that attribute, what is what is the, say if I talk about the canal system, then what is the width of the canal, what is the flow condition in the canal, what is the depth of the canal. So, all these information and even suspended particles, turbidity and other things, all this information can go as attributes in our this polyline database, and which can be used to develop this connectivity. So that we know that how resource will flow or how people will navigate within these channels if that system is also there. Now, among other network elements, there are basically we can divide in three kinds of network element. The first one is the edges, and edges means here to connect other elements or junctions, because like in case of drainage network, we may start with first order of streams, then two first order streams as per one scheme of networking, then these two first order streams can become second order stream, and likewise. So, are the links over which agents travel or the resource travel. So, edges is one element, another element is the junction, and these junctions basically where these networks will join. So, these networks or junctions connects edges and facilitate navigation. Navigation mean here is not always from transportation point of view, means like ship or boat navigation. It may be a navigation of vehicles or navigation or flow of certain resources like water or other things. So, a common term is being used here is navigation, is not always mean that is a transport related thing, and from one edge to another edge through this junction. And finally, the third element of network element is the turns, how the bendings are there, how the store information that can affect movement between two or more edges. So, those three elements are important, and they are basically developed, and when one digitize a network, these things will lie in the system as simple polylines. Now, this network has to be developed, and once it is developed using all these three basic elements, edges, junction and turns, then we can employ for further analysis. So, now in among the network elements, that if we discuss individual and in combining, the edges and junctions form the basic structure of any network, and the connectivity in a network deals with connecting edges and junctions to each other. As it is easy to understand that all that information has to be residing into our database, then only network analysis can be performed. What I mean here is that if all polylines are lying in isolation, as we call as in a spaghetti model, like in a plate of noodles, all nodules are lying in isolation, though they are in a group, but there is no connection between them, and therefore individual elements are there, then network analysis cannot be done. So, finally the turns, the third element of network, that the turns are optional elements that store information about a particular turning moment. For instance, maybe a left turn in case of in a traffic or some other scenarios. So, there that kind of information is also very much required. Now, what are the network resources which has to move? So, there are three basic types of resources that can contribute in creation of network data set. The first one is the edge feature sources, another one is obviously as per the elements, the junction feature sources, and third one is the turn feature sources. So, individually these sources basically then allow us to model the things, predict the things. So, like if I take example of edge feature sources, the line feature, because these are polylines basically, classes contribute as edge feature sources, and whereas junction feature sources, point features which are classes contribute at the junction feature sources, and the turn, as you know, that it is keeping information because it is a vector, basically it is a vector. So it is not difficult to know which is on the right side and which is on the left side, because this is a typical vector. So turn information can also be stored or developed in our GIS database, especially related with network. And these each feature a class that contribute to a network as a source generates elements based on its assigned role. So we have to basically assign what are the different roles of different these features or sources. For example, a line feature class is used as a source for edge elements, and a point feature class is used to generate junction elements. So different features, that means different vector entities, will be employed for different purposes. And then of course turn elements are created from a turn feature class, and then these generated junctions, which will be junction or edge or turn elements, form the underlying graph, which is the network. So once that is done, then network is created. In future demonstration, I will try to bring that one also, that how this network we can see on the system. Otherwise, when we will be discussing surface hydrologic modeling, definitely this discussion will come in much detail. So in this geometric network features classes cannot participate as a network data set resources, because they are actively linked to a geometric network. So we have to develop a different, and what are these feature classes that participate as a source in a network data set can participate in a topology. So remember, then when we were discussing about topology, we mainly focus at that time on polygon, path polygon topology. There it is equally important, but at the same time when we go for network analysis, then topology for polyline data is also important, because each feature has to know, or each junction has to know, that from which direction the resource will come. So which is on the left side, which is on right side, everything has to be developed within our network database. And a network is a system of connected linear features through which resources flow or communication is achieved. Now I have already given examples of various kinds of networks which we see in our day-to-day life. And one network is from natural system is like drainage network, canal network, and there might be a electricity power cable network. There might be network related with the some like traffic or rail network, road network. And nowadays there are various OFC network, very common nowadays, which we see. So this among resources we can keep ourselves also. So like movement of people, transportation, distribution of services, allocation, delivery of resources occurs through a network system, and that network may be a road network, rail network also. So everything if organized can be modeled, that how these resources will flow from one end to another, and the movement along these lines or these polylines or network is affected by other elements and their characteristics in the network, and that means that if there are too many junctions, then it will affect our, if there are too many turns in our network, it will affect our movement of resources. So that is another very important thing here. Now these network functions are used in analysis that requires moving resources from one location to another. So the key word here is the moving resources. Of course, if anything is not moving, then it is no network is basically required. So moving resources, that moving resources may be water, may be sediments, may be gas, may be electricity, anything. So in this, GIS is used to perform network analysis such as prediction of network loading. Basically what we are doing through network, and initially we may employ this network analysis of GIS about the predicting how things will move, what would be the load on the existing network. And we can also, this will become the part of modeling. But in day-to-day monitoring also, especially like power management, there in day to day this GIS analysis is being employed, the network based analysis. Also, this is a very common application of network analysis of GIS is about the determination of the shortest path, and that shortest path between connected points or nodes within the network based on the attribute values. And let me give you one example here. A few years back I read that in some western countries, the newspaper man, he wanted to know the shortest path to deliver newspapers every day through in a part of a city. So he wanted the shortest path, optimum path through this GIS analysis. That can also be done, and by which the newspaper hawker can save his time and resources also. So even to that extent, network analysis of GIS can be employed. Sometimes instead of calling network analysis, some software in literature you may find another term which is used is called route optimization. Basically finding the shortest route or finding the optimum route, that is route optimization. You might have seen in our example like Google Map, if I put that I want to travel by road from Roorkee to Dehradun. Now immediately it will show minimum 2 routes to me. One is via Haridwar, another one is via this Chotmalpur and Mohand. And for both routes, it will let me know that what is the distance of these 2 different routes and how much time it is going to take depending on the present traffic conditions. So, how it gets the present traffic conditions, that is another very interesting. It is coming through crowdsourcing and through the mobiles. So, if traffic is moving normally, smoothly, then that means these mobiles of individuals who are in the cars or vehicles, which is a moving resource, they are changing one tower to another in a normal way, and therefore the route would be, that part of the route would be shown as a blue color. And if it is moving slow, it might appear as yellow, and if it is really stand still, that means individual mobile is not changing from one tower to another, that means there is a traffic jam. So, both routes will also show this information which is coming from other, and of course there is a other algorithm which is working in the background, that it only shows along the roads. If side of the road, if there are 1,000 people have assembled for some function, that information will not come on the road. So, only information about the crowdsourcing of vehicles or people who are having mobile are in vehicles, that information is shared. So, immediately you know the 2 routes, distances and traffic conditions. And also you can choose that I may follow the longest route, but it might take less time or convenient. And further it also tells us that whether they are having toll plazas or not, because some people would like to avoid toll plaza because of crowding sometimes at toll plaza. So, all that information, from where it is coming, if it definitely it is coming through network analysis of GIS. And whatever the information about mobile density and other information which I am telling you, which is being used in network analysis, is coming as attribute values, and it is getting updated almost every minute or so. So, attribute may be simple as minimal distance, as in case of like a road example I have given, or more complex involving a model using several attributes defining rate of flow and cost. And this is how it tells or predict that if I start now from Roorkee to Dehradun, then this much of the time it is going to take. And of course, then using distance and speed, we can also determine the cost. I am sure in future, as per your vehicle's design or average mileage, it will start also predicting that how much it will cost. So, those things, it is nothing but coming from attributes. So, that has to have the information about the type of car and mileage, then it can be also predicted. So, this network analysis is used for route alignment, optimization of route, optimal path, shortest path identification, allocation problems, and some resources are not reaching at the, say, a minor canal is not getting water. What is the problem? So, that those problems can also be solved. And then of course, it is also linked with the distribution problems, because through network you are distributing resources from one end to another, and therefore, if there are problems, bottlenecks, junctions which are creating problems can be solved by through this modeling. Now, further in this network analysis discussion, that it the facilities management is based on the network analysis. Facility management I have already told, like these taxis, which are nothing but the facility management. Similarly, the big truck operators or the fleet management, they use also. Indian Railways have also started employing GIS along with the GNSS, that is Global Navigation Satellite System, to know where exactly different engines, because on the engines they have installed these receivers, GNSS receiver. So, on the network immediately they know that where a individual engine is, and which train it is, at what speed it is traveling, how much time it would take, and in future we are going to have a very good prediction about the timing or late of train based on all this through this network analysis and facility management. So, specific areas which are benefited or applications could be to determine optimal and shortest path as routing analysis, allocating resources based on demand and capacity, and based on a set of connected linear features. For example, the network, that is what we are discussing, that form a framework through which resources flow, maybe a road network through which vehicles move, a drainage network through which water or sediments flow, electric lines for electricity passage, and several other such applications can be there. Now, basically in network analysis, there are 4 components which are be considered. Apart from 3 basic elements, 4 components are that first is, if you recall our overall this discussion on related with the connectivity functions, there also we have been discussing that for different type of analysis within connectivity, like for proximity or others, which are these components are required. So, the essential components, first is required about a set of resources. What is the resource which has to move through that network? That much information is very much required. For example, sediments transported by water, that is one, or water itself is also a resource. Then location of resource, and when we are on GIS, location is not a problem, and we will get that information also. So, if for example, if I take a fluvial system, that means the drainage network or stream network. So, that I let you that information is there within the system, that which are the higher points, which are the lower points in this fluvial system. So, I would know from where to where the water will flow along with sediments. And then the third one is the destination, that is the outlet of the, for example, maybe outlet of a watershed, if we are thinking in terms of natural drainage system. And the final one is set of constraints, that these set of constraints can only be provided by the experts of that field. Those who work in this in hydrology, if we discuss about the water related thing, then a set of constraints. If somebody is good in power supply, then he would let us know what are the constraints, conditions, rules. And only for example, in case of this natural drainage system, only permanent stream of higher order which will have the water. Otherwise, generally you do not have water, means those are the perennial streams which are being discussed here. So, 4 components are usually considered, required before the network analysis. For example, transportation of a sediment in a fluvial system, route optimization such as airline scheduling, they too have started using GIS, employing GIS, urban transportation services for city buses, etc., for metros, for other like road networks, and subdivisions of municipal district into zones that can be efficiently serviced by hospitals and schools. There also, that how much time a kid will take to reach to the school. So, those optimization can also be done if that is required. And same with the hospital, same with the emergency services like for fire brigade, ambulance, etc. These things can be employed. And for example, also like subdivision of a forest into zones that can be efficiently covered by fire brigades in case of emergency. This is a very common thing in Garhwal, Himalaya, where every year in the month of April, May, or sometimes even June, we are having forest fires. So, we can, if we know which are the routes which are available, then the efficient system can be established, can be developed, so that the fire brigade can reach very quickly to the spot where the fire has occurred. So, this kind of analysis basically involves the identification of most effective routing, so that the fire brigade or ambulance or any emergency services can arrive to say fire as rapidly as possible. Now, further discussion on network analysis as said will be in the next lecture. So, for time being, thank you very much.